Okay, let's pick up where we left off at. So I was saying this 1 here, we want to choose this point because it has a 1 and 1s are easy to work with. 0s and 1s are easy to work with. This here has negative numbers and doesn't really make a difference. As long as it's a 1, it just makes it easy. So our x is going to be a 1, our y is going to be a 3, our slope is going to be 2.5, and our b we don't know yet. We're going to solve for it. So here we go. 1 times 2.5, that's going to equal 2.5 plus b, and that's all equal to 3. If we subtract 2.5 from both sides, these will cancel, and I mean both sides of the equal sign. That's when I say we're subtracting it from both sides. And what we're going to end up with is a half. 3 minus 2.5, we're going to be left with just a half. So 0.5 equals b. We'll put a little squiggly box around it. Okay, so now we got that much. Let's go ahead and get our equation. Y equals mx plus b. Let's sub in what we know. We know our slope here is 2.5. Our input's x, and our intercept, our b, is at 0.5. And that's for these 2 points, -3, -7, and 1, 3. So if we go back up to the graph, we want to label that line with this equation. So -3, -7, -3, -7, and 1, 3. This one is 1, 3 right there. Let's go ahead and make a line going through that one there. Okay. Let me move that down just a bit. So for this one here, this line right there, that's the one we just drew. We'll say y equals 2.5x plus 0.5. So y equals 2.5x plus 0.5. And that takes care of that page. So now they ask us, would you consider any of the 3 lines you just graphed to be a line that best fits the 3 points? So they're asking, does it best fit the 3 points? If yes, explain your reasoning. If no, describe where the line of best fit should be drawn. Okay, so with what we just did, each of those equations, they only went through 2 points. None of them went through all 3. So really, none of the lines that fit all 3 points. The line of best fit should have to be drawn so that it's passing between the 3 points, because we don't have a line that'll fit all 3. So let's write that out. No. None of the lines fit all 3 points. The line of best fit it'd have to be drawn between all 3 points. Drawn passing between all 3 points. Okay, that takes care of that. So we used the calculator earlier to do interpolation, and we got a line of best fit. Now there's another method. It says one method to determine the line of best fit, or linear regression line, that's what we did earlier, is the method of least squares. Least squares regression line, so I want to underline that, least squares regression line, is the line that best fit, that minimizes the squares of the distances of the points from the line. For a least squares regression line, ensure the line is written in the form of y equals ax plus b. Here they use a instead of m, but it's still the same concept. To calculate a and b, use the equations, and these are the equations right here. So we have this equation right here for a, and then we have this equation right here for b. And at first those equations, they seem intimidating, but I always tell you guys that math is the easiest thing. It's just numbers. You just break it down, follow each number. Look at what this guy says right here. Look what they even tell you in the book. Wow, that looks like a pretty complex formula, but I bet if I were to look at each part separately, it won't be so difficult. That's what we're going to do. We're going to look at each part separately. This is easy. It's not that bad. So they're saying where x represents all the x values from the data set, y represents all the y values from the data set, and n represents the number of coordinate pairs in the data set, basically your points. So your coordinate pairs, those are all your points. Like we had 3 points we just graphed. So that's all n is. So if we go down a little bit, they explain each of these little pieces in here. And all it is we're going to sub in all of these. You calculate them and you sub them in. It's easy. It's not that big of a deal. Let's use the formula to determine the least squares regression line using these points. So we've got point 1 right here, point 2, and point 3. So you got 3 points. Calculate the values of each part of the equation separately, then put it all together. Determine the number of coordinate points in the data set. So the number of points, here's the first one, here's the second one, and here's the third one. So you got your x and your y for your first point, your x and y for your second, and your x and y for your third. 3 points. There's only 3 points here, so n equals 3. So when we look up here, your n would be subbed for 3. For that n, we would sub in 3, and for this n, we would sub in 3. That's all it is. Determine the sum of all the x values in the data set. So right here, this is a Greek alphabet letter, and it stands for sum. Sum meaning just add up all the x's. Anywhere there's an x, add them up. So right here, it's saying sum up the x's. So here's your first x value. So we got x and y. This is -3, so notice right there the first one's -3. Go to the second point. The x value is a 1, so we got the 1. Go to your last point, x value is 3, so we got the 3. Now what happens here is you got a -3 and you got a +3. These two just cancel each other out. All you're left with is 1. So that's why the solution here is 1. So for the summation of x, you substitute 1. So anytime we go back up here, right there in parentheses it says summation x, we would put 1. Right here it says summation of x squared. So that's a little different, and they'll show us how to do that at the bottom. But right here, again, summation of x, so we'd sub in 1. Right here is summation of x times y. That's different, so we can't sub it in there. Similarly, summation of y. That's not x. We can't do that. Summation of x squared. That's different. We don't want to try and do that here. We just only want to do this symbol right here because they've shown us that part, and that's 1. Okay, let's take a look at summation of y. Determine the sum of all the y values in the data set. Pretty simple. Now we take the y's. So in the first point, our x is negative 3, coincidentally our y is negative 3. But we're focusing on that negative 3 because it's a y. So we put negative 3 there. We look at our next point, and the y value is 2, so we got a 2. We look at our last point, the y value is a 4, so we put a 4 down. Now, we sum them, we add them. Add means sum. Sum means add. So, 2 plus 4 is 6. We could do that, 6. And then negative 3 and 6 is going to be 3. And that's what we got right there. So for the summation of y, we would go back up here, right there. We'd put a 3 for summation of y. Right here, summation of y, we could put a 3 there. And those would be the only places. We wouldn't do this one or that one. Only the ones that match up, summation of y and summation of y. That's it. Okay, so now we go to the next page. And we continue on this. Not that hard at all. It says determine the sum of the squares of the x values. Okay, so this is how they want you to do this one. Summation of x squared. So you take each of the x values from each point. So you got the first point, so negative 3, so negative 3 squared. Negative 3 squared, that should become a positive 9. And then we go the next point, the x value is a 1. 1 squared is a positive 1. And then the next point's a 3. 3 squared is going to be a 9. Well, 9 plus 9 is 18, plus 1 is 19. So that's what we get right there, 19. And then we just go back and we sub in for the summation of x squared, we sub in 19. So then over here, summation x squared, 19 goes there. This one has parentheses, that's important. It is not the same as this one, two different things, so 19 does not go there. This one is summation x squared, no parentheses, so 19 would go there. And those are the only places. Oh, right here, summation x squared, parentheses are on the outside, so that's different also. That the main thing is the part that's inside is all intact, the way we need it, so we can put it there also. Okay, so let's take a look at the next part. Summation of x times y. That means you take each point and you multiply the coordinates for them. So the x and y coordinates right here, the first point up here, negative 3, negative 3, well, you got your x coordinate times your y coordinate. Negative 3 times negative 3, and then plus your x coordinate times your y coordinate, because it tells us right there x times y. So we do this one, 1 times 2, 1 times 2. Next point right here, 3 times 4. And if we do that, 3 times 3, well, negative times negative is positive. 3 times 3 is 9. So we got 9 plus 1 times 2 is 2. So then 9 plus 2 is 11. 3 times 4 is 12. 12 plus 11 should be 23. And that's what we get. Pretty simple stuff right there. So then we would just sub in, we look for this symbol, anywhere we see this symbol we put 23. So summation of x times y, we put 23 there. Summation of x times y, we put 23 there. Summation of x quantity squared. Notice these parentheses here, they mean quantity. So the quantity inside is squared. So summation of x quantity squared. And now they did equals and they put 1 squared. Why would they do that? They skipped some steps. I don't like that. So let me go ahead and explain those steps that they skipped. There we go. Okay, our x values. So our x values here, we would end up with negative 3 plus 1 plus positive 3. And if we did that, we would cancel out that negative 3 with that positive 3, and that's going to equal 1. So they went from this step right here to this, and this part is squared. And that's how they get to that part there. Really, they should put I should put a bracket like this and square that, because that's what they want. They want this whole thing to be added up, so this whole thing's added up, then squared. So we added it up and then squared it. If it helps, I could put brackets here too to help you see how those two are connected. And that's how they get their 1 right here. So anytime you see the summation of x quantity squared, you'll put a 1. So now that we've gone through each of those, now we go to the bottom and we just sub them in. So the summation of x times y, notice they put 23, and right here, summation of x times y, we talked about it, there's 23. The n, we did the n first. The n was 3, remember, because there's 3 points. So right here, 1 point, 2 points, 3 points, so n is 3. So we sub in n is 3, summation of x times y is 23, minus summation of x, the summation of x was 1. We got that right there. Summation of x is 1. And then summation of y, our summation of y was 3, so they got 3 right there. And then they're dividing it, so we put the division symbol. Then they put n again. Remember, our n is 3, so we put 3 right there. Summation x squared. So right here, summation of x squared, we got 19. So for that one, we put 19 right there. See, summation of x squared, 19, minus, we got our minus, summation of x quantity squared. And that one's right here. Summation of x quantity squared. We got a 1, because there's a 1 there. Sorry, that's the one right there. And then you would just crunch all these numbers. You could do them in your calculator. You could do them, you know, longhand, multiplying them out. You should end up with 66 over 56. And if you divided that in your calculator, you'll get a long number, but it's approximately, if you round it out, it's approximately 1.18. And that's our A. And then for our B, we do the same thing. We sub in all these values, just like we would do for A, and we'd get our B value. Now remember, the point of all this is to get the line of best fit, but the method is least squares regression line. So we want to take these and put them in a line where it's y equals ax plus b. And that'll give us our line of best fit with the least squares regression line method. So let's answer this question here. What is the equation of the line of best fit for the points given in the worked example? So to do that, you just use what I just wrote down right here. We take this, y equals a times x plus b. Our a is 1.18. So y equals 1.18 times x, and then plus our b. Our b is 0.61. So the equation of the line of best fit for the points given in the worked example is y equals 1.18x plus 0.61. Okay, now they want us to calculate one. Oh, no. They want us to correct someone. It says Margie calculated the least squares linear regression for the worked example. And there's a thumbs down. and this is Margie's work here, A equals n times the summation of x times y minus quantity summation of x times summation of y, the quantity of summation y, all divided by n times the summation of x squared minus summation of x squared. Okay, let's take a look at this. Is this equation even correct for the A? Let's just compare it. Let's see, n summation xy minus parentheses summation x parentheses summation y divided by n summation x squared minus parentheses. So you got the parentheses here, summation x squared. She's missing the parentheses here. So let's just make that note. So she's missing parentheses here. If she's missing the parentheses here, what do you think it does to, see there's the minus, so what do you think it does to that? So if we compare what they got for A, let's see here, for A, in the worked example, they've got 1.18. Here she's got 1.74. Notice right here, they've got 1. Right here, they got 19. In the example, this is 1. Explain to Margie why her solution is incorrect. Okay, so she left off the parentheses and it threw off that number and made her answer incorrect. We could say right here also, answer is supposed to be A is approximately 1.18. So now that we have all those notes, we can begin to construct our answer and be thorough. Let's see here. Margie forgot to write summation of x quantity squared instead of summation x squared in the denominator. Ooh, getting a little tired. As noted above. We could also say maybe she doesn't know the difference between summation of x squared versus summation of x quantity squared. And summation of x quantity squared, period. Uh-oh, let's see here. I need to move that up some. They ask us to calculate the least squares linear regression using points from question 1. Calculate the sums and values of each part of the question. Okay, hang in there with me. This isn't that bad. This is actually really easy. So let's go ahead and write the points down. That's the easiest thing to do so we can stay organized. They want us to use the points from problem 1. So let me get those points. Calculate the sums and values for each part of the equation. We need the points first. 1, 3. And then we also need -3, -7. And then we need 5, 7. Those were the 3 points. Okay, so here we go. What we're going to do is we're going to run right down these. We've got n equals the number of points. The number of points, there's 1, 2, 3. So n equals 3. Really what I'm doing here is I'm going through the last page right here. See, check this out. The last page, I start off with n equals 3. I go to the next one, summation of x. So then I'm going to write down right here, summation of x equals, and then I just take all my x values. So I'm going to add them up. The first one is a 1, so 1 plus, the next one's -3, -3 plus, the next one's 5, 5. And then I just go ahead and add them. So 1 plus 5 is going to be 6. Minus 3 is going to be 3. Takes care of that. So I know that's going to be my value for the summation of x. For n, I got a 3. Let's see here. The next one is summation of y. See right there, summation of y. That's the next one on the list. So my first y is a 3. Because it's sum, we're adding. My next y is -7. My next y is 7. So these two are going to cancel each other right here. Bam, bam, they just cancel each other out. +7 and -7 equals 0. And then all we have left is 3. So there we go. Let's see here. We've got to do summation of x squared. So let's go summation of x squared equals, we're going to take each of our x's and square them. So we got 1 squared plus -3, -3 squared plus 5. We'll go 5 squared equals, 1 squared is going to be 1, and then -3 squared, well, 3 times 3 is 9, negative times negative is positive. So right there, we got a 1 plus a 9, that's going to be 10, and then 5 squared is 25, so we should end up with 35. Because 25 plus the 10 over here we're adding, so we get 35. Alright, now let's do the next one. They say it's, let's see, we did summation of x squared, summation of x times y. So summation of x times y. Now we take all the points and we multiply them. So we take the first point, 1 times 1, 3, coordinate 1, 3, and we multiply those. 1 times 3 plus negative 3 times negative 7, negative 3 times negative 7 plus 5 times 7. So then we go with 5 times 7. Okay, so we're going to end up with 1 times 3 is going to be 3 plus negative 3 times negative 7. Negative times negative is positive. 3 times 7 is 21. 5 times 7 is 35. If we add all these up, we should get 59. Okay, last one here. Summation of x quantity squared. Summation of x quantity squared. Okay, so for this one, what we want to do is we could actually look at this right here, summation of x. See how it's inside the parentheses? So we could look at that, summation of x. We go across, we get 3. So really, summation of x, we just use this previous one. We know the summation of x is 3, so we can put that inside and bring over our power of 2, our square. Power of 2 is square. We square it, and we get 9. There's all our values. Now that we got our values, it's just plug and play. We'll have to use the calculator a little bit if we want to move quickly. Okay, so it says calculate the values of a and b. So I'm going to write down the formula for a. A equals, I'm going to work horizontally. I don't like working horizontally, but for these equations I will, because they've got the divider symbol and they didn't give us a lot of room to work this out. Minus summation, quantity of summation x times the quantity of the summation y, all divided by n times the summation of x squared minus the quantity of the summation x squared. Okay, so to solve this, all we gotta do is plug and play. So our n is going to be 3. That n is 3. Summation of x times y. Summation of x times y is 59. So we plug in our 59. Okay, and we got the x times y, so now we get our subtraction symbol going there. Summation of x, that's a 3, times summation of y is 3. N is 3, so right there n is 3, that's the number coordinates. Summation of x squared is 35. Minus summation of x quantity squared. Summation of x quantity squared, that's a 9. And if we plug all that into the calculator, what we should get, let's see here, 3 times 59 minus 3 times 3, oops, that should be 3. And that should be 168 all over 3 times 35 that should be 96. And if we divide that out, 168 divided by 96, we should get 1.75. So we know our A is going to be 1.75. That's our slope. Our B, so let's get our equation going for B. Let's see here. We're going to do summation of y quantity times summation of x squared minus summation of x summation of x y all divided by n times summation of x squared minus quantity summation of x squared. Now all we got to do is just sub in the values we calculated up here down here. Summation of y was 3. So we'll put a 3 right there. Summation of x squared, summation of x squared, and we got 35. So we'll multiply that by 35. And then we're going to do the subtraction symbol. And then let's do summation of x. Summation of x is 3. Summation of xy. Summation of xy is 59. Divide all that. N is 3. Remember, n is 3. Summation of x squared. Summation of x squared is 35. Subtract from summation of x quantity squared, and that's 9. Okay, let's go ahead and crunch some numbers here. 3 times 35 minus 3 times 59. That's a negative 72. All over 3 times 35 minus 9. That's a 96. So negative 72 divided by 96. And we end up with a negative 0.75. And that is our y-intercept. That's our B. Okay, now that we're there, they ask us write the equation of the line of best fit. So for that, we go y equals a times x plus b. We bring down our y. Our a is 1.75. And then we bring down our x, and we add our b. Our b is a negative 0.75. And that's our line of best fit using the least squares linear regression. Let me go ahead and put a squiggly answer bubble around it. For the next problem, they ask us to graph the line on the coordinate plane in question 1. Does this line fit the data better than the others? Explain your reasoning. So, we go back to question 1. And they want us to graph this. So if we graph it, we're going to use that y-intercept, because the y-intercept in it is what's going to help us. The y-intercept is negative 0.75. So that's like 3/4, negative 3/4. So if I look on here, on the y-axis, negative 3/4 would be about, so negative 1's there, negative half there, negative 3/4 would be in between. And then our slope would be 1.75, that's our b. If we were to take that and turn it into a fraction, we would have 1 3/4. So if we have 3/4 and a 1, that 1, we could say it's 4/4. Add it to the 3/4, it would be 7/4. So for 7/4, that would be our rise over our run, 7/4. So we go up 7 and then over 4. So 1, 2, 3, 4, 5, 6, 7, and then we go over 4. 1, 2, 3, 4. And we can put a dot right there. And then we could go ahead and connect the two. So that line right there should be between all 3 points. If you notice this point here, the gap there between this point and then this line here, where these 2 points touch, it's fairly equal. Let's go ahead and label this one here. This one here is y equals 1.75x minus 0.75. So a lot of stuff we got in there. Okay, so now that we've done that, if we go back and we look at that last question, so it asked us to graph the line on the coordinate plane on question 1, or in question 1. Does this line fit the data better than the others? Simple answer, yes. This graph is a better fit than the others. So we stated our answer, but why? So it's a better fit than the others because we got to defend it. It is closer to all 3. All 3 are. Gotta fix that there. It's closer to all 3. All 3 what? All 3 points. Even though it does not pass through any of them. All right. So for problem 2, we are good. I'll do problem 3 in another video.